Let's take a look at the spacesuits of the Artemis generation. So to be clear, Christine is wearing a spacesuit that will fit all of our astronauts when we go to the moon. And it is also true that we have with Christine Amy Ross, who is a spacesuit engineer, and we have Dustin Gomert, who is wearing not a spacesuit that we're going to have on the surface of the moon, but on the way to the vicinity of the moon. So these are our spacesuits for the Artemis generation. Amy, if you would share with us a little bit about how this design for the Artemis generation is maybe different than the design for the Apollo generation.
Sure, I'll be happy to do that. We've been working for a long time to build spacesuits that will do the job on the moon and going on to Mars. So basically, my job is to take a basketball, shape it like a human, keep them alive in a harsh environment, and give them the mobility to do their job. So one of the things we've looked at is trying to reduce the space here, make a smaller unit, display and control unit here, and get those shoulders to where she has a lot more mobility to move. So she's able to do a cross reach and get across the suit, as well as reach overhead, which they can't do today and couldn't do during the Apollo program. Then in addition to that, we also, because this is the first time we've gotten to build a suit specifically for a planetary surface, we have a lot more mobility in the lower torso. So we have a waist bearing, and we have 3 bearings on the legs, as well as a flexion extension joint here at the waist. And that gives Chris a lot of capability to move around and do whatever tasks we might need to do for science and maintenance on the planetary surface.
So just so everybody knows, Christine's spacesuit is under pressure right now. And that usually makes it very difficult to mobilize. And yet, what is she doing? She's moving around. If we remember the Apollo generation, you remember Neil Armstrong and Buzz Aldrin, they bunny hopped on the surface of the moon. Well, now we're actually going to be able to walk on the surface of the moon, which is very different than our suits of the past. So if you would, Amy, tell us a little bit about the thermal environment on the moon and how this suit is going to be helpful in that environment.
Yeah, we normally try to plan for a thermal environment that ranges from 250 degrees Fahrenheit to minus 250 degrees Fahrenheit, with some potentially colder spots in the south pole of the moon. And so we are looking at the materials and the protection for this suit to keep our astronauts comfortable while they perform their job.
So you're saying that Christine in this suit would be able to be at plus 250 degrees Fahrenheit or at minus 250 degrees Fahrenheit in the exact same suit?
Yes, we can. And so for the moon, we're using materials that allow us to do that. And when we go to Mars, we're going to need a new insulation because that has an atmosphere in Mars, and our insulation depends on the vacuum of space right now.
Awesome. And then when we talk about the South Pole, which of course is the goal, we want to get to the South Pole of the moon. It's really cold. Are we going to need to make modifications to this spacesuit for the South Pole missions?
So one of the things we're looking at to go to the South Pole is if we need to design some specific thermal systems for the boots, some cover layers, and maybe some active heating to keep your toes warm.
So the goal is to get to where all of the water ice is. We know that water ice represents life support. In other words, it's air to breathe, it's also water to drink, it's also rocket fuel, and it's on the South Pole of the moon. This is really amazing. I hope everybody understands the mobility of this suit is astonishing under that much pressure. So let's talk about the pressure. Another risk of being in deep space is the vacuum of space. So tell us, what kind of pressure is she under? Is it 100% oxygen, those kind of things?
Certainly. So this suit is designed to operate at 8 pounds per square inch of pressure. Like I said, a basketball is operated around 7 to 9 pounds per square inch of pressure. If you put your finger and your thumb together, and put it on your shoulder, there's about 14 pounds, 15 pounds worth of air pushing down on you right now. So it's a fairly heavy pressure. And then she needs to be able to move under that pressure. So we have to make the suit flexible under pressure. We use 100% oxygen because we're trying to protect the astronaut from decompression sickness. And so that high oxygen concentration and the high pressure then allows her to go out and do a spacewalk quickly and not have the bends, which is decompression sickness. And then we can bring the pressure down because we have a new technology in the life support system, the backpack, that allows her to come down to a 4 pounds per square inch of pressure and have more flexibility in her gloves while she works.
And the gloves are key because your dexterity, show us if you can move your fingers. Can you move your, she can't hear us because she's in the vacuum right now. She's under pressure. Yeah, so that's really, really impressive. Okay, so another big challenge when we go to the moon is the lunar dust, which is extremely fine-grained and can be very damaging for spacesuits. And of course, we had to learn this for the first time in the Apollo program. So now we can take what we learned and apply it here. Tell us what we've learned and how we're doing things there.
Yeah, so my mentor worked on the Apollo suit, and two things I learned were zippers are bad and cables are bad. So we have no zippers and cables on this suit. What we have are bearings, so we can move easily in that pressurized suit. And what we need to do then is protect the bearings from the dust. And so we have seals in the bearings. We also are designing our environmental protection garment so that it helps mitigate the dust as well. There'll be fewer seams and new materials that keep the dust out.
That's fantastic. Let's give Christine a big hand. Oh, by the way, before we do that, she's going to show us how to pick up a rock, if she can handle it. And she can.
It's a heavy rock.
This is difficult to do in a spacesuit. All right. I got the rock. Thank you. Okay, so she's under pressure right now, and she could very well run out of air very shortly. So she's going to be exiting the stage, and we're going to bring up Dustin.
Do you want me to take the rock?
I'll just set it back down here.
Okay.
So Dustin is wearing a different type of spacesuit, and Amy, I guess Amy will come back a little later. But Dustin, tell us about the spacesuit you're wearing and how it's different than the spacesuit that we're going to wear on the surface of the moon.
Yes, sir. Good to be here. This suit is the Orion Crew Survival Suit. And so while the mission of that suit is to what we do when we're there, this is the suit that gets us there and gets us home safely. And so this suit is fully integrated with the vehicle from the ground up. So when it's tailored to the human body, it's also tailored to the seat. So we have 100% fit in the vehicle and 100% integration with the Orion ecosystem. So
when you say ECLIS for the audience.
Oh, yes, apologize. We speak in lots of acronyms. So yes, the
environmental control and life support systems.
Yes, sir.
Okay. Got it. Okay, so your suit is generally going to be depressurized, which gives you a lot of mobility, flexibility, and of course, when you're flying in deep space, you're going to be just fine without the pressure in the suit. Why would it need to be pressurized when you're in a pressurized capsule?
In a pressurized capsule, we don't necessarily have to be pressurized in this suit. There may be some future cases of decompression sickness mitigation that we might want to use it for, but the primary use is in the case of an accidental depressurization, we can take safe haven in this suit. We'll seek refuge in here. We'll keep the body at 8 psi for a certain period of time, and then we'll drop down to about 4.3 psi, and we can remain there for up to 6 days. And so that's no small feat to be able to live in a volume that's only a couple inches bigger than your body for 6 whole days.
This is, in essence, when necessary, a spacecraft. And same as the space suit that we just saw for the XEMU, which is how we're going to walk on the surface of the moon, it is a personalized spacecraft for a person walking on the moon. In other words, so let's pretend you do have an unfortunate depressurization kind of situation. Maybe a meteorite impacted your vehicle, punched a hole in the capsule, you still got to get home. Now you've got a spacesuit that is providing all of your life support. That's the intent, right?
That's correct, sir.
So other than the life support, what parts of the mission will you be having? You'll be able to get out of this suit when you're in deep space.
That's correct. As soon as we get to orbit, the crew will nominally take the suit off. We talked about the word doffing this morning, which is to remove the suit. We'll stow it for the most of the mission, and we won't put it back on till it's time to come home. Once we get home, though, it's not just the suit that provides us safety in deep space. If we had a contingency on landing, this suit is designed for all the aspects of the post-landing safety for the crew as well.
So it has thermal protection?
It does have thermal protection, not the same as what the XCMU has, though, in terms of the radiation environment of space. But internally and under this suit, we'll wear garments to manage our thermal environment with liquid cooling.
Awesome. So I just want to say thank you to you, Dustin, another spacesuit engineer. Amy, who was just up here, spacesuit engineer. Christine, who was in the XEMU, which is the spacesuit that we're going to use to walk on the moon, also a spacesuit engineer. We have some really talented people. Remember this. We, as the Artemis generation, are building spacesuits that will fit all of our astronauts. We want every person who dreams of going into space to be able to say to themselves that, yes, they have that opportunity. And that's what we're working on right now at NASA.